Okay, we'll go sum and differences of functions. So in order to deal with sums and differences of functions, we have to be very familiar with our function notation. So f standing for this specific function, when the variable x is included, is equal to x squared, which is, if we recall, just our standard parabola with a vertex at the origin. G at x, g still standing for a different type of function, involved with the variable x is equal to x, which is a linear relationship. This is technically the power of 1, and it's got a slope of 1 that pretty much crosses at the origin. That wasn't drawn properly. So they've decided to develop two different functions here, h at x and j at x. And essentially what they are is the sum of the two above functions and the difference of the two above functions. And there's a rule called the Superposition Principle that says that you can essentially graph this new function, I guess we'll call it the superposition, we'll write it in. Superposition. And the principle, is it PAL? No, PLE, that's it. Because I always end up spelling it backwards, like a school principal. Superposition principle says that we can add the y values, so if we add or subtract, depending on what we're doing with our adding and subtracting functions, the y values to graph the new function. And what they mean by that is from the graphs of the old function. So the first thing we'll do is algebraically build our two new equations. Now these are relatively simple equations to put together. So we'll start with the sum of them. So we'll find h at x. So h at x, like it said, was equal to f at x plus g at x. Well, if we recall, f at x is our parabola, x squared, right? So we're going to be replacing f at x with x squared, and our g at x was our value of x. Okay, so what we can do here is we plug those values in. This becomes x squared plus x. So we now have a quadratic, and maybe if I want to make some sense of it, because this is technically in standard form, if you recall, we can factor it. Now there's nothing wrong, we're technically done. This is the sum of the function. If I factor it, it gives me a little more information. I can easily find my zeros of my function, right? Well, quickly, if we set it equal to 0, we know x is 0, and the other one was when x is equal to -1. They'll be our two zeros of this function, which gives us an idea about the vertex and everything, because this is quadratic. Now, what we really want to do is we want to take a look at x squared and x. So we'll go, do I have it up there? No, I don't yet. I'll move it to the other page. Okay, so we've put them up here, and our x squared is our parabola, while our x, like we said, is our linear equation here. So according to this, what we can do is we can sum. Now here's a coordinate here. We should be able to add the y values to find the new y value of our new function. So because, and we'll just take this specific point here, they both happen to be a y value of 1 when x is 1. So if they're both 1, if I add 1 plus 1, what should my new y value be? 2. 2, yeah. So let's put in our new function, x squared plus x. And when x is 1, can I not click it? I guess not. There you go. Our y value happens to be 2. Okay, so we've summed the blue and the red together. Now, if you notice, 0 and 0 still ends up at 0. Now, because y is negative at this point, let's see if I can find a good number here. This one, at 0. Essentially, what's happening here at -1, okay, our y value is +1, and here our y value at 1 is -1. So +1 and -1 equate to 0. So if I wasn't able to graph this function, as long as I could graph the other two and just added all their y values, I could find the new graph of our function straight from that. And we know we're correct because recall we decided one of our x-intercepts was -1 and the other one was 0 when we factored it, right? And our vertex happens to be in between those two. So that's the sum of that function. Okay, let's go take a look at the difference of the function, our j at x. J at x gave the same idea, but this time it was f at x minus g at x. Okay. Same idea as before, only difference is a negative in between. So again, we're going to replace, whoops, that's the wrong one, wrong color. We're going to replace our g at x with the value of x and our f at x with the value of x squared. So the only difference now is we have x squared minus x. So same idea, but this time let's factor it out and take a look at our new differences. It would be x minus 1, which means our intercepts are still 0, x at 0, and the other one is x when it's +1, so it's probably just shifted. compared to what it looked like before. Now with that same idea, we should be able to subtract our values on our other page. So let's go to our other page, and I'm going to write this in, x squared, and I'm actually going to turn it off because I just don't want to see it yet. Minus x, okay? So we haven't seen it yet, but using this same principle, because we know that both these values are 1 here, that same spot we talked about first. 1, when we subtract the two y values, 1 minus 1, what should our new y value be when x is 1?
0.
0. So let's take a look. And if we take a look here, when x is 1, our y value is 0. So they've subtracted the red and blue function to find the graph of the purple function here. 0 and 0 ends up being the same. And because we're subtracting large negative values, we end up going in a upward direction here with our purple. Okay. So again, if we were unable to graph our new function when adding them together, we can just add our y values and recreate that entire graph. Okay. Same here. We added them here. Here we subtracted them. That was the only difference between the two. And what we'll do is, I guess we'll make a little printout of that.